again for Equatorial Launch Australia's third launch from the Arnhem Space Centre. I'm Dr. Brad Tucker, and I'm going to be here with you to see this great day, to see this third launch as part of this campaign between NASA and Equatorial Launch Australia to explore our southern skies. And look, it's exciting. For those who were with us on that first launch, there were so many emotions. We were at the edge of our seats, waiting for those winds to die down, but it did take off. As of now, we will be updating you, obviously regular through the next half hour, but we are on track for just now under 30-minute launch for this rocket. And this will be, again, as I said, the third mission as part of this campaign. And this is the DEUCE mission, launching an extreme ultraviolet imager spectrograph to look at our nearest star to us besides the sun, Alpha Centauri. And we're going to talk a little bit more about that later today. Now, this broadcast is being brought to you via a number of places. And we have to recognize and appreciate the beautiful country that we're all on here in Australia. The rocket is on, and the broadcast, and myself. And for those who don't know, in Australia, we just finished celebrating NAIDOC Week, celebrating the great history, science, knowledge, and tradition of Aboriginal and Torres Strait Islander people who have been on this continent for over 60,000 years. And the Arnhem Space Centre is located on the Yolngu Nation, the Yolngu country. I am actually being brought to you remotely from Canberra, so I am in sync with the cameras, but I am in Canberra, which is on the traditional lands of the Ngunnawal and Ngambri people. And we also are coordinating via Ghana country, and that is in Adelaide. And so this is really a national effort to bring you this beautiful rocket that's going to take off in just under 28 minutes or so now. And we're going to be great to see the amazing science and hear from the scientists who will be looking at it later. So it's a great day, great night. I hope you're strapped in, because the rocket is strapped in as we speak, ready to go in its position. Again, as of now, the winds are cooperating. I know those who are watching on the first stream heard a lot of "let's reset to 3 minutes." I hope to never hear that phrase again, minus the one I just said, and it will be a fun time. Now, in order to start our celebration of science today, we will have Jawa do a welcome to country from the Yolngu people.
Hello everyone. Namere Bukmak. Hello everyone. My name is Jawa Yunupingu, and I'm one of the traditional owners where Arnhem Space Centre is. I would like to take this opportunity to welcome you all to a country of the Gumaj people.
And so now you can see where we are on site. So in your video, as you see the rocket in position. The rocket is set up and ready to go in that vertical launch position. Now, it is on the left. Obviously, it's being lit at the site. Now, for those who have never seen a sounding rocket take off, or any type of rocket, or you missed the first launch, well, boy, did you miss an excitement. These sounding rockets, what we call suborbital rockets, they go into space. Tonight, we will be going 250 kilometers above the Earth. So that is lower than where the International Space Station is, but still actually into proper space. It will spend about 5 to 10 minutes collecting science data in total. The first science data will actually start taking only 100 seconds after launch. And we are using a Black Brant 9 rocket today. Now, this has 2 stages, which you can kind of see in your screen. There's the bottom stage and the top stage. And these things, boy, do they sure take off. They are in a hurry to get into space. It's like when my dog hears the fridge opening, boy, do they run for it. Now, it will be taking off super quick, as we'll see later today. And the weather, this is, again, the big question I know we all have. The weather does seem to be cooperating. There are a few clouds about. The clouds are not an issue here. The clouds will not essentially prevent this rocket from taking off. Obviously, if we have a downpour of rain, there may be a slight pause. And for those who watched the first rocket launch, remember there was times when there was a ton of rain coming down, and it was so loud inside the room I was that you couldn't hear it. For the locals, now, for those of you who are wondering, can I see this rocket? If you're in the general larger region of the Arnhem Space Centre, Nhulunbuy, you will be able to see it. Now, a note to those people who are watching, we love that you're coming out to watch this rocket. Remember, there may be a delay from our stream to what you see live, and this depends on buffering on any end for the internet. And so some people can experience a minute or so of delays relative to the real time they're experiencing, meaning that, as we get close to those 30, 50, 60 seconds ready to get takeoff, get ready to go outside and see it. Now, if you're not in that general vicinity, if you're not kind of in the Arnhem area, Nhulunbuy, that area, you will not see the rocket. If you're in Darwin, you're too far to the west. Queensland, you're too far east. And up below, you won't see it. So you need to be within about 100 or so kilometers, really, of the Arnhem Space Centre in Nhulunbuy to really see what is happening and to have a chance to it. And again, we'll remind you later, but just keep that in mind as you're watching tonight to make sure that you're kind of staying in tune with what's going to happen and just buffering that chance to make sure you can go out and see it. Now, we are ready for this launch today, and it's going to be really exciting. Now, for those who, again, remember the first launch, we experienced about 1 hour and 14 minutes worth of weather delays. That was purely to wind. But the mission was a success. It was launched. It worked. It was amazing. It was a great experience for all. The second launch, and this was launching the Sistine mission. Now, the Sistine mission and the DEUCE mission are both by the University of Colorado. And we're going to hear from Kevin France, the project scientist for this campaign, a little bit later today about these projects. And the Sistine mission had quite a number of delays. And again, this is all weather. And this isn't, unsurprising. Weather happens. The biggest factor has been the dry season in Arnhem Land, which is supposed to be dry, stable air. It's been a little bit unstable. And for those who are wondering why you really focus on the winds, there's two levels of winds, really. So as that rocket is mounted, you worry about, obviously, it swaying, any danger or safety. Again, safety is the highest priority here, both of people on the site and downrange as the rocket takes off, because this rocket will go up and it will come down and land. And we're actually going to show you the recovery that happened with the first and second missions. So it's a really exciting thing to actually see the rocket bits being recovered. I'm going to show you that a little bit later today. But we also worry about the winds higher, and that's because as the rocket takes off, again, it never reaches full orbit. It never stays in space orbiting the Earth. It does what we call these suborbital launches. Now, the wind can both blow it off trajectory, it can kind of steer it away from its intended target, or it can change its speed, all of which can slightly slow down the rocket, again, changing the altitude or the height it reaches, what we call apogee in space, the furthest point away from Earth it gets, and then therefore the science can achieve. So all of these things are why the winds are the thing that is monitored and checked. And so we are constantly monitoring the wind with the team. One of the operations manager, Daryl Moody, is providing real-time data to us, as well as Clayton on site. So we're all tuned, ready to go. And everyone says it's looking a great day for a rocket launch. And that's what you love to hear, right? You love to hear it's a great day for a rocket launch. And so it's going to be a great day for all of us. Now, we also brought the launch up early a day. So originally, we were scheduled for a 12 July takeoff. Now, having monitored those winds, the decision was made that tonight, 11 July, was looking for a better time, with a little bit of worry about weather, and that may have come in later in the week, and therefore moving it up a day meant that it was a more secure chance of launching it on time. Now, I should also remind you that there is about a 3-hour launch window tonight. So even though we're scheduled for taking off in, not just over 20 minutes, that time of launch can extend for 3 hours. So it can be delayed due to the winds, due to all sorts of number of things. And as I said, the guest for tonight is a Black Brant 9 rocket. And we were able to get a little bit up close earlier in this launch campaign to see exactly what it's like and to see it up close and personal, the big, beautiful rocket that's going to go do some amazing science for our understanding of the universe. So let's take a look.
So we're at the rocket launch site right behind me. So the rocket is now into its vertical position. So what you have to do is obviously the rocket starts lying down in the shed, gets into the launch position, ready for takeoff. So we're at the dress rehearsal now, but it'll be put into position tonight for the launch, and soon it will take off.
Brant 9, all 3 launches have been using the same rocket design. Now, the Black Brant is 9. There's multiple versions of it. This is a 2-stage rocket, so we mean there's 2 distinct stages, as you're seeing now, plus the payload that sits on it. Now, the Black Brant 9 rocket is what we call a solid-state rocket. So instead of using liquid fuel, quite a lot of rockets use a combination of sometimes methane or hydrogen and oxygen, kind of fuel as you imagine that get pumped in. This has a solid propellant, meaning that inside the rocket, the propellant is staying there. There's no need to pump in fuel, essentially. Now, that has quite a number of advantages operationally. It has a number of advantages for something like tonight, and that is these rockets, as we said before, they move really quickly, generating almost 7,800 kilograms of thrust, or about 15,000 pounds of thrust, in those first 26 seconds, essentially, of takeoff. And then by 100 seconds after takeoff, DEUCE, the dual extreme ultraviolet channel explorer, will be taking data for 5 to 10 minutes as it's in space at that apogee height, that peak height of 250 kilometers, coming back down and then delivering that critical data. And the target for DEUCE tonight is Alpha Centauri. So Alpha Centauri is a binary star. In fact, there's a 3rd star we call Proxima Centauri on the outside. But Alpha Centauri A and B is the what all the fuss is about tonight. It is the star attraction, pun fully intended, for tonight. And it will be studying the properties of that star, what we call the extreme ultraviolet, between 50 and 90 nanometers. So much bluer, much more extreme than kind of the ultraviolet light that maybe you experience in the summer when you get sunburned. So it's an amazing system. It's going to deliver some amazing science. And the team has been working tirelessly to get here. Keeping in mind, the countdown, we are getting really close to that time. We're just about 15 minutes away, a little bit longer now, just about that. We're closer, but they've been at it for almost 8 hours. It takes a long time to get all of the rocket tested, integrated, all of the various steps, all the checks ready to go. And we saw some amazing excitement with the first 2 launches. Now, the first launch, as we know, was streamed live. And, I think it was fair to say that those who tuned in watched me I was a tad excited. It was my first launch. It was my first launch live. It was, as we talked about, the first commercial launch in Australia, NASA's first full commercial launch with a partner outside the US. It was an amazing historic event for Australia, for Equatorial Launch Australia, and even for NASA, in addition to the science that was delivered. And the excitement was just buzzing through the entire space community. And it's an exciting part of where we are in Australia, delivering the exciting science, the exciting future of space. And so we're going to relive a little bit of that experience from the first launch. And now the second launch was also not live streamed, but we did record it. And because so many people said, yes, we want to see the rocket, we want to be excited just like you, please allow us in. That's why we're bringing it here. Now, logistically, it is really hard to pull this off. And that is because of all of the infrastructure that goes in to the Arnhem Space Center. Obviously, operations of the rocket is the first priority. It's the true point of the show. So making sure that we can work around safely, effectively, and complement what is happening there is all part of the goal tonight. And hopefully you're enjoying it. So we're going to relive a little bit of that first experience of the first and second rocket launches.
5, 4, 3, 2, 1, go!
Yeah, you know, as we said, these rockets really take off with a fast speed. And on that first night, we had a number of clouds. There was a lot of rain about, but that didn't stop it. It was just waiting for the pause in the wind, which eventually came. Eventually the wind came, the rocket poking a hole essentially in the clouds as you're seeing. And the second launch, once we eventually got the weather, once the weather cooperated to get to that second launch, it was pretty smooth sailing. There was still a long wait on the second night to get to it after having a couple of days of delays.
8,
and this is the second launch.
6, 5, 4, 3, 2, 1. Now seeing operation of the Arnhem Space Center having these regular launches. And again, this is the third and final part of the launch. So NASA had came down here to do 3 campaigns, or as they say, 3 missions as part of this campaign rather. And this is the third, but it's not the final one. This is the beginning of a new industry, a new amazing part of the space community here in Australia. And so already people are thinking about when's going to be the next launch, who's the next customer. We know NASA's going to come back. When, we're not quite sure, probably in a couple of years. But there are so many groups building rockets, building satellites, and needing a place to launch from. And this is the beautiful thing that Australia is developing. We have so much expertise in developing satellites, from monitoring floods to bushfires to improving GPS. We're also now building rockets in Australia. And now we have the final part, and that's a place to launch us all from. And so it's an exciting time. And so as we live these moments of seeing rockets take off and seeing the enjoyment of these science experiments, some of which in some cases have waited 10 years to get down here. Sistine, which was the second mission launched, it was built essentially just to launch and stare at Alpha Centauri, the target for tonight. Now, DEUCE, the third payload, the one on the rocket tonight, has observed multiple times, but it's always been a wanting to observe Alpha Centauri, again, the target for tonight. Now, this day really, as I said before, has started 8 hours ago. It has been a long process on site, of getting it ready. And I think the beautiful thing about the Arnhem Space Center is just how unique it is. The fact that you have the beautiful red dirt that we'll show you here in a second, and the nature of the rocket's takeoff. It truly is an Australian endeavor, from the engineers and scientists
workers and the people who come here who are working at Arnhem Space Centre from all over Australia, plus the locals and the traditional Yolnu people who are helping on the recovery and the science of it. It's a beautiful relationship to make this work. Now, so for those who are just tuning in, we're not quite 9 minutes away from this rocket taking off. The winds are cooperative, the weather is cooperative, and it's going to be a good day to see a rocket take off from the Arnhem Space Centre. Now, if you are a local, as I said before, the counting on the live stream may be out from you in reality, and that's because of buffering on the internet and that sort of thing. So make sure you give yourself a good 60 seconds, minute and a half before we're ready for that final takeoff to go outside and get ready. And you have to be in the general Nhulunbuy Arnhem area to see it. So let's take a look behind the scenes now of what it's like to get this rocket ready at the Arnhem Space Centre.
5, 4, 3.
And as we said, it's a beautiful facility. Here we are in the Launch Control Center, and this is obviously pre-recorded now because there's a lot of busy people here right now getting it ready. And the facility is supported by so many staff, scientists, technicians, people dealing with data, Marco, who is responsible for all of this communications and navigation and connection on site, getting this all ready to go and operate. And it truly is a remarkable place. I don't think there's anything like it in the world. And I think it's fair to say that really is one of the most remarkable space facilities and unique space facilities really in the world. To build a facility like this that, as you see, can host a rocket that takes an extreme ultraviolet imager spectrograph that looks at the properties of our nearest star to us besides the sun, Alpha Centauri, characterize its environment to figuring out what is it like? What are the properties? Is it a good place to potentially look for planets and habitable planets in the future? And yet in such a remote part of the world, there is so much infrastructure that has gone into making this facility work, to making this rocket ready to go, to getting it ready to see a new way of seeing in the universe. And this is what we're just about 6 minutes away now from seeing. We are still on track now for a launch in just now 6 minutes. And it's going to be exciting. We're going to see the rocket take off. And remember, this rocket moves like it's really late for dinner. This thing is going to take off so fast. It will go into orbit, or not orbit, but space, suborbital space, reaching about 250 kilometers at its peak apogee, spending about 10 minutes total collecting its science. And even though there's some clouds about, that is not what is going to prevent anything. It is whether the winds pick up at the surface or higher level or higher above at a higher level, and if there's any rain. As of now, it's pretty stable. For those who watched the first one, notice we had a lot of wet droplets on the lens. And I know a lot of people wanted us to clean it and get closer to it. Well, for safety reasons, you obviously can't have someone there wiping a lens as a rocket that generates 7,800 kilograms of dust is about to take off. But as of now, no rain, stable winds. We are under 5 minutes now from this rocket taking off. And as I said, this is going to be looking at the extreme ultraviolet part, so 50 to 90 nanometers. So this is much bluer, say, than what you would experience kind of in your everyday. We hear about ultraviolet A and B light, maybe the thing that burns us in the summer. That's like 320 to 400 nanometers. This is much bluer, much shorter than what we can see with our own eyes. And it's very important for understanding the science. And we're going to take a quick look and chat to Kevin France, who is the head scientist as part of this campaign, and the person wanting to see this beautiful data. So Actually, we already realized we're so close to the countdown. We'll catch up potentially with Kevin later. He's quite busy as of now. We are good to go. We are just checking now on the status. So yeah, so it looks like we're now about T minus 3.5 minutes to go. We are getting closer. We're almost not that at that time. Oh, it's exciting. It's perfect. Even the clouds are parting perfectly for us, ready to go. And we will bring you, as the rocket takes off, we will bring you the launch view here, and we will follow it as quickly as we can, as fast as we can, to get it into space and see at 250 kilometers, what is the nearest star to us, Alpha Centauri, again, besides our sun, looking like in these extreme ultraviolet, what is the property? So we are now actually resetting to T minus 7 minutes. This is not a weather delay. This was just a check they had to do. So we're now 7 minutes out. So we'll update that. So we will have time to bring you Kevin in a second. There is no weather delay. This was just a double check that they did and a syncing of the count and the process of the steps. So far, no wind delay, no weather delay, green to go. Every light is now green. This rocket is going to be taking off very soon. And so we're going to catch up in a second now with Kevin, as we said, who is the lead scientist for this entire campaign and the designer of Sistine, the second mission that happened a few days ago, and heavily involved with DEUCE, which is the object, the payload, the science for tonight.
Hi, I'm Kevin France from the University of Colorado. I'm NASA's campaign scientist for the ELA launches. I'm also the principal investigator of the Sistine mission, which is going to launch on July 4th. I've been working on this project for about 10 years, trying to find a way to bring our telescopes to the southern hemisphere to observe Alpha Centauri. We're just extremely excited to be here at this beautiful new launch site, be able to launch on the 4th and see this exciting ultraviolet data of Alpha Centauri A and B.
Kevin is the campaign scientist, right?
That's right.
And the second mission, though, is a tad closer to your heart?
That's right, yeah. I'm also the principal investigator for the second mission, the Sistine flight that's going to go on July 4th.
Now, what is Sistine going to do?
So Sistine is an ultraviolet spectrograph that's going to study Alpha Centauri, very beautiful southern hemisphere sky, bright star. And we're going to study the ultraviolet radiation from that star to understand how habitable planets may exist around that star.
So yeah, so Alpha Centauri is that star near the Southern Cross that
That's right.
we love to look at. And so how many planets do we know of around Alpha Centauri?
So there's a debatable planet around Alpha Centauri today, but it's a huge target for finding and searching for Earth-like planets around solar-like stars. So Alpha Centauri is actually a spectacular twin of the sun. And so being the nearest sun-like star, it's the focus of a lot of our efforts to find Earth-like planets.
Yeah, because it is that, that rough idea that maybe one day missions could be sent even to Alpha Centauri in a very distant future, at least.
Right.
But it's the closest we get, really.
That's right.
Besides our sun.
That's right. It's our best shot to find another, Earth 2.0.
So when you say ultraviolet, so what do people mean? So in Australia, we're very used to being sunburnt during the summer. So is this the sort of same ultraviolet light that you're looking at?
It's actually even more ultraviolet. It's all part of the larger electromagnetic spectrum, but the rays that we're worried about at the beach are, we call them in wavelengths 300 nanometers.
Yep.
We're about 3 times shorter wavelengths than that, down to about 100 nanometers.
And so that means you're also probing hotter bits of the star in the system.
That's right. It's also why we have to put it on a rocket, because we have to get above Earth's atmosphere, which is the protective layer is great for us when we're at the beach, but rough if you're trying to study the light.
So that's the only way, right? So you have to put this on a rocket up there to see it, and because the target is in the southern hemisphere, you need to launch
from the south.
From the south.
That's right. That's why we've been asking NASA to do this for 10 years, because there are these beautiful targets in the southern hemisphere we just can't observe from our normal launch sites.
Now, you have a little bit to do also with the third mission, part of your broader team?
That's right. So the third mission is also coming from the University of Colorado, and I developed the science case for that mission as well. It's all part of our larger team that works together, and it's observing even farther ultraviolet light, what we call extreme ultraviolet light, which goes down to about 55 nanometers, which is really short wavelengths, yeah.
And is it also going to be looking at Alpha Centauri as well?
That's right. It's studying Alpha Cent 2. The idea was that the Sistine and the DEUCE missions, Launch 2 and Launch 3, would be like a joint science project.
Okay, yeah.
And they would just cover different parts of the spectrum because we don't have one instrument that can do it.
Look, it's great to have, and we look forward to seeing Sistine and DEUCE in orbit looking at Alpha Centauri.
Absolutely.
And so we are now T-minus 2 minutes, 30 seconds, ready for this rocket to take off. As I said, all systems are green. Everyone is giving the proverbial thumbs up for this rocket launch to happen. I am ready for it. I hope you are ready for it. And again, there are a few clouds, and as some people notice, you can even see a few stars through some of those clouds. It's a beautiful night, a beautiful evening for a rocket launch. T-minus 2 minutes and counting. We are almost there. We are getting so close to this rocket. And again, if you are a local in the Nhulunbuy-Arnhem region, make sure you are out now. There may be a delay in our stream, ready compared to what you're experiencing live. And you don't want to be looking at me when you should be looking at that rocket taking off. T-minus 1 minute, 30 seconds and counting now. This will be taking off. It will be launching to take the extreme ultraviolet imager and spectrograph DEUCE to look at our neighbor star to us, Alpha Centauri. Again, looking at both of them, Alpha Centauri A and B. Oh man, we're almost there. The wind seem ready. I know some people are like, are we going to get another delay? We went through this. No, as of now, it seems to be cooperating. We seem to be good. The winds are stable. Everything is cooperating. T-minus a minute now, 55 seconds. We are getting really close. We will be following this as quickly as we can, ready for this rocket to take off. Oh boy, if you saw me excited in the first one, you know I'm going to be excited for the third one. Who can't be excited by a rocket launch? We're going to go take a look at the nearest star to us in colors of light that we cannot see from the ground. T-minus 30 seconds. Get ready. This rocket is about to take off. We are close. The rocket is close. The rocket is ready. Oh man, 20 seconds and counting. And we will follow it as quickly as we can. But, you know, this rocket moves in a hurry. T-minus 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. And it's going. Woo! Yeah, man, this thing moves so fast. Go, go. Yeah, do it. Whew. Man, you can see the smoke haze left behind on this rocket. We did get on some other shots, and we'll bring that to you in a second. As I said, this thing takes off. It is now into space. It is getting there. We're already on our way, and only 100 seconds after takeoff, they're already acquiring data. So the science team is about to kick into action to get ready for it. Oh man, there goes the rocket. Oh yeah, who doesn't love this? This is amazing. We are seeing a third rocket launch from Australia take off. And as I said, I warned you, this thing takes off like it's in a hurry, and boy, it did. It took off to get there into space to get ready to look at the extreme ultraviolet part of Alpha Centauri A and B. And so look, you know, it took off, the smoke is left. We'll get the replay of it as well in a second here so you can relive the vision. But man, it is amazing that this actually works, you know, because, you know, this facility was built to support these missions and others into the future. We can see a little bit glow into the sky as it's still going in.
It's going to reach its apogee of 250 kilometers. That is the peak height of where it will reach, and then it'll come back down. I warned you it goes fast. Your heart's pumping. You feel like you're just riding that rocket. And so now already what the science team is doing is they are allocating the imager to get locked onto Alpha Centauri A and B. And in fact, we will get they will get the data of it actually pretty quickly. By the time already now, obviously, we're not bugging them because they're trying to get their science while their payload is in space. They're locking on to get their data, and they will be analyzing it already. They will be getting it down. They will be figuring out what's going on. They will be figuring out, is it, getting it? In fact, there's someone with a little control stick that's getting it aligned perfectly to get all that data. And now that we're a few minutes post-launch, we're clearly now having this payload in space. It is looking at the extreme ultraviolet collecting this data. And so, for those who don't know a little bit about the history, the Arnhem Space Centre has been built for the past few years getting this ready. And it's built out of nowhere, so to speak. There was no space center here. From getting the launch pad, the infrastructure, the data, the communications. I mean, there's 6 satellite dishes just to relay the data, just to get this and the trajectory. And you know what? Let's appreciate this. This is a new spaceport that has just had 3 successful launches in 3 weeks. I mean, this is an amazing feat. This is not something that has been set up before. Building this new site from scratch, getting it ready, and now they have had 3 successful launchings, looking in the X-ray, which was the first mission, and now different parts of the ultraviolet spectrum, looking at Alpha Centauri A and B. It is a great applause for everyone at the Equatorial Launch Australia and the Arnhem Space Centre. People have been working for hours on end for weeks to get this ready. It is an applause to all of you and to the vision of the team at Equatorial Launch Australia that has been building this for a decade to get it ready. I think it's an amazing achievement. And, for those who have never been in Arnhem Land, not only is it a beautiful country, it is a very remote country. And when you go there and your phone doesn't work and there are no services, and so they have had to build this from scratch to get it ready, there is so much work when you have to build a facility that does the most amazing science in a location that is beautiful and challenging in so many unique ways. And they've been working with so many different partners like Yolnu Rangers who go out and recover the payload after. It is really amazing. I really love it. And we are all looking forward to future launches at the Arnhem Space Centre and Equatorial Launch Australia. This is not going to be the last one. This is the first set of many, as we hope. And as you can see now, people are starting to head out to the launch pad to start doing those assessments afterwards. The rocket, is part of the story. It is not the whole story. And even though it took off it had somewhere to be, and that was space. It is in space. And kudos to everyone who's pulling off. Thank you all to watching it. Thank you to the local community for supporting Equatorial Launch Australia, the traditional owners for supporting us. And thank you to everyone who's tuned in to watch me be excited by a rocket. I hope you've been excited by a rocket. I hope you've appreciated what we can do in Australia at the Arnhem Space Centre. Now, we will be signing off shortly, but we will be having this recorded on YouTube that you can rewatch, and we'll probably be posting more videos of the launch because who doesn't love a good rocket taking off? We all know I do, and I hope you do as well. Thank you for watching. Thank you for tuning in, and thank you for being with us on this historic journey for re-emerging Australia in the space rocket race.